So let's look at functions. You guys saw this in the introduction, where we were deciding what makes something a function or not a function. So, what makes something specifically a function? Somebody help me with this.
Wait.
It only has one output.
One output
For
each input. Which means if I put in a number, what is the input? What coordinate is specifically the input?
Y.
Is it X or Y?
It's
It is X. Remember, Y equals mx plus b. The Y is on the output side. It's all by itself. X is on the input side. It's with the rest of that formula. So you put in the X. What you want out of your equation in order to be a function is you want that number to be the same every time it comes out. Okay?
Okay.
Now, stop playing with your pants.
Sorry.
Why would I care if something's a function or not a function?
So if it's a function, something might go wrong. All right.
If it's not a function,
It changes.
will I be able to write a mathematical equation for it?
No.
No, if it's not a function, it's not going to be mathematically possible to write an actual equation for it. Because remember, math follows rules. If I have an equation and I put an input into it, I should always get the same output, right? So if it's not a function, it means I can't make it an equation. I've seen people taking high-level tests that try and solve an equation where it's not a function to start with. Now, you can find funky math to make it work with whatever set they give you, but if it's not a function, you can't make an equation out of it. Does that make sense? So let's look through at some of these. Mapping diagrams are probably some of the easiest to see. Remember, for each input, there's exactly one output. So I've got an input of 0. What's the output?
1.
How about an input of 1?
4 or 5.
Is that
No.
a function?
No.
No, this is not a function. Because I put in 1 and I could get the number 4 or the number 5 out, and neither one of those are the same. So I cannot find a mathematical equation to make this work. This is one of those where somebody's making a choice in the middle for something to change. Let's look at this one. If I put in 7, what do I get out? I'm not sure what you guys are all doing sidewise. 2. How about 8?
1.
9? 10. Is that a function?
Yes.
Because each input has exactly one output. Remember, they can share the output. So I've got 2 inputs that both equal 3. That's fine. As long as every time I type 9 in, I get 3 as the answer. Every time I type 10 in, I get 3 as the answer. Okay? So this is a function. Make you a little dizzy there with that move. You don't understand that?
The camera showed.
I don't understand how you put.
You shout them off.
Okay. If I put a 7 in there, if I type a 7 using this diagram here, what is the answer I'm going to get? Hold on. Let's see what's the answer I'm going to get.
2.
If I type an 8, what am I going to get? Over here, if I typed a 1, what was I getting?
4 or 5.
Is it always the same? So somewhere inside of whatever created this, there was a decision made. I write computer programming where you can make a decision. If it's 1 and it happens to be a sunny day, then it's 4. If it's 1 and it's dark, it's 5. There's a decision in there, which means it's not a consistent equation. Does that make sense? So over here, every time I type something in, I got only one thing out.
Oh, okay.
So it's a function. Let's look at the table. So table, what you're looking for in a table, stay with me. I'm not sure what you're doing, but stay with me. Okay, put it down. So on a table, you're looking for 2 inputs that are the same. If they give you a table and no inputs are the same, for you, as far as you're concerned, it's a function. They may say, well, what if this? Well, okay, I can deal with what ifs. Give me the number. And if it's already on that table and it's a different, then I can change it to not a function. let's look here. I got 4 and it comes out 3. 16?
8.
8? 0?
No.
4,
8?
2.
Well, I got 2 8s, don't I?
Yeah.
Do they equal the same thing each time?
No.
Then it's not a function. You writing of these? On this one over here, I've got an input of 14, it outputs to 52. Input 8, it outputs to 21. 27 it equals 16. 36 it outputs to 25. And 4 it outputs to 52. Are any of these inputs the same?
No.
Then it's a function. Does it matter if the outputs are the same?
No.
No, absolutely not. Don't let those confuse you. We don't care about the output when we're determining function. We just want to make sure that each input has exactly one output. Now, graphs get a little more unique in how we do them. What you're doing is you're looking for something in a line. So in a graph, I'm going to use a straight edge and see if any two dots going straight down, because this is your x coordinates, right? And this is your y. So are there any two x coordinates that are the same looking at this graph?
No.
So is it a function?
No.
Are there any two
No. Yes.
inputs that are the same?
No. No.
Then it's a function, right? Because each time you put in the number, what is this, 22.5, you get somewhere above $400 every time. We don't have another one on that line. So this is a function. Over here, again, I got a graph, x and y. I'm looking for x's, and I'm going up. What do you mean, yes?
There's 1.
Where?
It's 85.
This one at 86 here? Remember, they're going by 2's.
Oh.
These two at 86 are on the same x-coordinate, right?
Yep.
So one time we put 86 in, we got 300. The other time we got about 350, which means it's not a function. We're getting different outputs for the same input.
It's like 90.
So did those make sense? You guys, if you do yourself a favor and you circle things like I've been doing here, when you get to the problems, as you're going back trying to review what you did, the answer becomes obvious and you can quickly bypass and move on because you know your work. Don't be afraid to write on the paper. The worst thing I see in like STAR testing is people who just write nothing and just fill in bubbles. It kind of makes me sad
It's kind of like me.
because I know already they're not remembering their thought process. Put it down on paper. Let's look at the last ordered pairs. What are ordered pairs really? What are we looking at when we look at a pair of ordered pairs?
It's something that can make a plot on a graph.
You can plot a graph, so you're right. You could just plot a graph. What else could you do that we have here with ordered pairs? Could you do any of these three?
Yes.
Yeah. It's just a table, or you could do any of these formats. So when I look at ordered pairs, what am I really looking for? To decide if it's a function.
The input being the same.
I'm looking for two inputs that are exactly the same. You are correct, man. So let's look through. I got a 0 input because the input is x, right? I got a 2 input. I got a 3 input. I got a 2 input. Hey, there's two 2's, right? There's two 2's, aren't there?
Yes.
Do they have the same output?
No.
So what does that tell you?
Not a function.
Not a function. So identifying a function from data seems to be pretty easy. Why do you guys care? Here's the most common things you guys are going to see. You're going to see a table with a bunch of numbers on it, and they're going to say, write the equation of a line. But what if you've got two inputs that are the same, but each has a different output? Can you write that equation?
Yes.
No. Because it's not a line anymore. Does that make sense? So, to be an equation, I need to have everything in a line. If I have a table and I've got two input, two x coordinates are the same, but their y coordinates, their outputs are different. I know it's not a function, and I know I can't draw you a line. I'm going to write not a function. It means I can't do what you asked. Okay, stop coloring. Oh, you're not coloring. You're just playing with lovely bits. You were very amusing, Wesley, though. All right, any questions?
Bye.